Guys, I have designed a RC aircraft model using Fusion 360, and today I'm gonna test it on Autodesk CFD 2023. So the first thing I would do is to create a external volume, and this box that I'm creating will act as the wind tunnel. I will then edit the material of the wind tunnel. Obviously, I want to set it to air, and I'll click apply. And next, I will set the material of my aircraft. It is not extremely important at this stage since I haven't done the airframe design, and the statistics aren't going to be super accurate anyways. The main purpose of this test is to just figure out the general aerodynamics and troubleshoot any obvious problems at this stage. Our next step will be setting the boundary conditions. For boundary conditions, I am going to pick velocity, and I'm going to set it at 60 kilometers per hour. For the outlet of the wind tunnel, I'm gonna select pressure and set it to 0. Of course, this is gauge pressure because essentially we're setting the reference level at the outlet, so the pressure at the outlet is 0, and the pressure anywhere else is whatever it's going to be. Finally, I will click solver, and for iterations to run, I'll set it at 300 for now. If I need more, I'll obviously run more iterations. The more iterations, the more accurate the results will be, and obviously I'm going to run as many as I need for the convergence plot to completely converge. And for compressibility, I'll set it to compressible, and total temperature doesn't really matter here because I haven't turned on the heat transfer, and at such speed, heat transfer isn't something that we need to consider. And turbulence, we'll change that to turbulent, and we'll use the standard K epsilon model. Everything looks good, and we can start solving. Okay, it turns out that I have to run 711 iterations for the convergence plot to completely converge. And now what I would do is to use the calculator to obtain several data from the simulation. So I'll go to results and wall calculator. I would select volume, select all, and obviously I'm not interested in the forces acting on the wind tunnel itself, so I will deselect that. Forces, I'll pick newtons because I like newtons. It's the SI unit that I always work with. And torque, I'll stick with SI units as well. And the point on axis will be the pivot. So the torque calculated will be based on this point. And 0, 32.50 is approximately the center of gravity of this airplane. yeah, I mean, I'm only interested in the y-axis of the center of gravity since I'm only interested in the rotation about the x-axis, which is the pitch. I don't expect any yaw or roll, which is the rotation uh, about the z and y-axis during steady flight. So I'm not very interested in the torque acting about the y and z axis as well. Therefore, I picked the direction to be 1, 0, 0, which is the direction of the torque about the x-axis. Alright, so we can click calculate, and we go to summary. Alright, and as we can see, the forces acting on the x and y x direction is comparatively very small, which is ideal because during steady flight, again, we don't want any yaw, so we don't want any movement along the x-axis, and the force in the y direction will represent the drag. In this case, that's 2.3 newtons, and the force in the z direction will be the lift, which is 3.8 newtons. And we have a general understanding of the center of forces about each axis, and also the moment, which is the torque, about each axis. And as you can see, the torque about the y and z axes are very small, about 1,000 times smaller than the torque about the x-axis. As we can see from this diagram here, about the center of gravity, we have two forces, which I labeled F lift and small f. F lift will contribute to torque sub 1, which is going to cause a counterclockwise rotation, while small f will contribute to torque 2. That's going to cause a clockwise rotation, and ideally these two torques will cancel each other out. Another important quantity other than force and torque is pressure, and as far as I can see, the pressure distribution along the wing is perfectly normal, with some low pressure at the top and some high pressure at the front and at the bottom. And I can't see anything super strange right now, and I'm pretty satisfied with the results. Thanks guys.